Hello students, in this class we will discuss about one function, onto function and inverse function, inverse of a function as well. So let us quickly recall the definition of one function. F is said to be 1 F is said to be one function if fx1 equal to fx2, if fx1 is equal to fx2 implies x1 is equal to x2, or if x1 is not equal to x2, then fx1 is not equal to fx2. So this is the definition of one function. So with the help of this definition we can show that a function is one or not. Also f maps from x to y is onto if for arbitrary y belongs to y, for any y belongs to y, there exists x belongs to x, then f is onto. So I'm not going to the definition again. So we'll try to prove whether a function is one or onto with a simple example. We start with a simple example. Say f is a, let us say f is a mapping from set of natural number to natural number, and fx is equal to 2i6. So let us see whether this function is one or onto. Let fx1 is equal to fx2. f1, x2 is obviously x1, x2 obviously belongs to set of natural number. So this implies by definition, since fx equal to twice x, so fx1 is equal to twice x1. So twice x1 equal to fx2 is equal to 2x2. So this implies dividing the both sides by 2, we get x1 is equal to x2. So we see that the function is 1. Now what about onto? So let us say fx is same function, let us keep the same function, so whether it is onto or not. Now for onto we have to take one arbitrary element y belongs to set of natural number, then y should be equal to twice x. So y should be equal to twice x. Now if y is equal to twice x, this implies x equal to y by 2. Now whether y by 2 is natural number for any y? No, obviously not. Suppose if we take y as one odd number or natural number, then odd natural number by 2 is again not a natural number. So it is not necessarily a natural number. So this, for arbitrary natural number y, there is no x, we don't have x, which is again a natural number. So we go for counter example. We go for, in this case, when the function is not on 2, we give counter example. We write like this: f is not on 2. Directly write f is not on 2. Since we take any odd number, say 3, belongs to n, but there is no x belongs to n such that fx equal to 3. To become fx is equal to 3, twice x must be equal to 3. If twice x is 3, then x must be equal to 3 by 2. But if x is equal to 3 by 2, then 3 by 2 is no more a natural number. So that's why this function is not on 2. The function is not on 2. So in this way, we prove that the function is not on 2 with the help of counter examples. Now, how to show the functions are on 2, 1, 1 as well. So let us take one more example. Say f is a mapping from, let us take one function f is a mapping from, say, set of positive real number to this one minus 5 to infinity, and fx is equal to 9x square plus 6x minus 5. So we are going to use this example. We'll show whether this function is invertible or not, and if it is invertible, then we will find out it inverts as well. So how to show that? First, we'll try to prove whether this function is 1, 1 or not. For that, we'll consider let f of x1 is equal to fx2. So this is the way for proving 1, 1. So let fx1 is equal to fx2. fx1 is equal to fx2. Obviously, x1, x2 is positive real number. So this implies fx is equal to 9x square plus 6x minus 5. So fx1 is equal to 9x1 square plus 6x1 minus 5 is equal to 9x2 square plus 6x2 minus 5. So this implies 9x1 square minus 9x2 square plus 6x1 minus 6x2 is equal to 0. So this implies, if we take common 9, then x1 square minus x2 square plus 6 common, then we get x1 minus x2 equal to 0. So again we can factorize this. X1 plus x2 into x1 minus x2 plus 6 into x1 minus x2 is equal to 0. So from here we can take common what? x1 minus x2 we can take common throughout. So then taking common x1 minus x2, this implies x1 minus x2 into 9x1 plus 9x2 plus 6 is equal to 0. Now as x1, x2 is positive real number, we have written already x1, x2 are positive real number. So 9x1 plus 9x2 plus 6, obviously it is not equal to 0 because sum of three positive real numbers cannot be equal to 0. This implies x1 minus x2 is equal to 0. So we have got x1 is equal to x2. So therefore f is 1 1. The function f is 1 1. Now let us check its ontoness. So whether the function is onto or not. Here the function is fx is equal to 9x square plus 6x minus 5. So let us take arbitrary let us take arbitrary y belongs to the set of this one range, that is minus 5 to infinity. That y belongs to minus 5 to infinity. Therefore y is equal to square plus 6x minus 5 will take such that this one. So this implies 9x square plus 6x minus 5 plus y is equal to 0. So actually for finding the ontoness we have to solve this equation. We have to find the value of value of x in terms of y. That is the technique. We have to find the value of x in terms of y. So we see this is a quadratic equation in x. So how to solve this equation? This can be solved as thrice x whole square plus 2 into 3x, making this perfect square, plus 1 is equal to 5 plus y plus 1. So 3x is same here. So this implies 3x plus 1 whole square is equal to 6 plus y. So this implies 3x plus 1 whole square is equal to 6 plus y. This implies this implies 3x plus 1 is equal to plus minus square root of 6 plus y. So this implies 3x is equal to minus 1 plus minus root over 6 plus y. So ultimately we have got x is equal to minus 1 plus minus root over 6 plus y divided by 3. Now x is equal to minus 1 plus minus root over 6 plus y by 3. If we take the positive number here, plus sign here, then x is equal to minus 1 plus root over 6 plus y by 3 is a positive number and belongs to R plus. That is, it belongs to this set. In this set, it belongs to this set. Or moreover, fx is equal to f of, if we take x, this one, minus 1 plus root over 6 plus y by 3 is equal to 9 into this one, minus 1 plus root over 6 plus y by 3 whole square plus 6 into minus 1 plus root over 6 plus y by 3 minus 5. It means we are substituting the value of x, this one, in this function, and we get this is equal to, here 9 get cancelled, we get, after simplification, we get this is equal to x. If we simplify it, we get this is equal to y. This is equal to y. Once we simplify it, we'll get this equal to y. So we have gotten x, which is equal to minus 1 plus root over 6 plus y divided by 3, such that fx is equal to y. So therefore f is onto the function f is onto. So hence f is onto. So in this way we can prove the function is 1, 1 and onto. So f is invertible. So invertible can be proved in this way, whether function is invertible or not. If it is asked to prove the function is invertible, then we can prove it in this way. Simply you have to write f is invertible. If we are asked to find out the inverse, f is invertible, we write this one with here with f inverse y, which is equal to the value of x, and value of x we have got as minus 1 plus root over 6 plus y by 3. 6 plus y by 3. So this is what the f inverse y is equal to, f inverse y. So we can write f inverse x as f inverse x is equal to minus 1 plus root over 6 plus replace y by x divided by. So here we complete, and the complete topic is how to find out inverse, how to show that function is 1 1 as well as 1 2. I hope it is quite clear and you can work out the examples yourself. Thank you.